episode 11 of the World of FPGA podcast. There are many different manufacturers of SoCs on the market. In this episode, I'll give you an overview over the most common SoCs with an FPGA core inside. Welcome to the World of FPGA podcast. I'm your host, David Kirchner, and I will lead you through the world of FPGA. And now, let's begin. As discussed in the last episodes, a system on a chip, or SoC in short, is an integrated circuit. It combines various components of an electronic system into a single chip. These components can include a CPU, memory, input-output interfaces, other peripherals, and also an FPGA core. While SoCs and FPGAs serve different purposes, they can also be combined to create highly optimized and compact systems. In recent years, several manufacturers have started offering SoCs with built-in FPGAs. And in this episode, we will explore some of the major players in this space. And I'll put all links to the different devices into the show notes, of course. The first manufacturer is Xilinx. Xilinx is a leader in this FPGA market, and they are offering SoCs with a built-in FPGA for several years. It begins with the Xilinx 7000 series, which combines a dual-core ARM Cortex processor, Cortex A9 processor to be clear, together with an FPGA fabric. The FPGA fabric can either be an RTX 7 architecture or a Kintex 7 architecture. You find the RTX 7 architecture in the Xilinx 7000 7 to 20, and the Kintex architecture in the Xilinx 7030 to 30 to I guess 100 or 70. I'm unsure, so I most time use the RTX architecture. A little period of time later, the Xilinx UltraScale Plus MP SoC takes a step further. It combines a quad-core ARM Cortex A53 and a dual-core ARM Cortex R5 processor with an FPGA fabric. And also some additional features has got included, for example, I think a graphic core you can have, or memory and things like that. And the newest kind of SoC from the company Xilinx is the Versal platform. This platform combines FPGA logic with an ARM core, an ARM multi-core processor, and it had also some cores for artificial intelligence. That's from the company Xilinx. Now go a step to another company, to the other big company, the company Intel. Well, Intel has bought the company Altera several years ago. Well, the same as Xilinx is now AMD, but Intel is also another major player in the SoC together with FPGA inside. Well, they have different devices with a different architecture, and the first one is the Area 10SX SoC FPGA. Well, this is quite the comparison to the Xilinx 7000 because it's an FPGA with a dual-core Cortex A9 processor. And I think Intel has done this before, Altera has done this because of the Sync 7000. The next device is the Stratix 10 SoC, which combines a quad-core ARM Cortex-A53, well, also the same as the ultra-scale MP SoC, just with a high-performance FPGA fabric. And there are also some other devices, the Xilinx series. There are the Xilinx 9, 7, 5, and 3 FPGA family. I guess that has something to do with the iCore 9, 7, 5, and 3. That's the numbering from Intel. Well, this family has, for example, also quad-core ARM Cortex-A53 processor and many high-performance features. Well, I didn't want to go too deep into the different devices because you're able to read, I guess. Then we have the company Microsemi. Microsemi is now a subsidiary of Microchip Technology, and they are also offering two different parts of SoCs with built-in FPGAs. On the one hand, we have the SmartFusion 2 SoC, which combines an ARM Cortex-M3 processor together with an FPGA fabric. And the device is, it's focused on low power application. Interesting is this device has also flash memory included and also volatile memory included. So for some applications, for some maybe bare metal easier applications, you didn't need external memory for your ARM Cortex-M3 because you have everything on this chip and you can use it as you have bought it. And the second device Microsemi delivers is the device PolarFire SoC. And now we have an SoC which has not an ARM core. This device has multiple RISC-V processors. That's different to all the other SoCs I've mentioned in the last minutes. Well, and at this, they have multiple RISC processors, and interesting is they have a master and they have slaves as RISC-V processors. So you can have, for example, some of the processors are having the operating system, and one core is doing a real-time process, which is always on the same time spot. That's quite interesting, and that makes it different to Intel and Xilinx. Well, these are the three companies I'm knowing that they have SoCs on the market. I thought Lattice is developing an SoC, but I haven't found it yet on their homepage. Maybe I haven't looked deep enough. Another possibility to have some kind of SoC is that you put into your FPGA logic and processor core. So it's quite easy possible to have a soft processor core in your logic, which is doing your controlling and communication stuff. And for example, Xilinx has the well-known Microblaze processor. It's a 32-bit processor, and most time we would run there a bare metal application written in C or C++. I guess it's C. And I have heard from this, I haven't tested it yet. You should also be able to run a Linux on a Microblaze processor. Well, but you can also put another kind of processor into your logic. For example, you can instantiate a RISC-V processor in your design and using this for your application. But it's always important to know that these cores which you are putting into the logic didn't have the high performance and also the quite low power of a hard processor IP core. My conclusion is the combination of SoCs and FPGAs offers the designer a flexible and highly optimized solution for a wide range of applications. Xilinx and Intel are the two major players here, but also other manufacturers are offering interesting solutions. The variant with a soft processor core could be also a solution for your application. And as technology continues to the advanced, we can expect to see even more innovative SoCs with built-in FPGAs in the future. Well, I hope that I haven't forgotten an important manufacturer. If so, then please send me a message. You can reach me out at LinkedIn or via mail. All links and some further information you can find at world-of-fpga.com/WFP011. If you found this episode helpful, please rate it on Apple Podcasts and share it with your colleagues and friends. That's the end of today's podcast episode. Thank you for listening and for your attention. So I say goodbye here next time, your David Kirchner.